let's take a moment to get familiar with the platform. You can open the chat, tell us where you're tuning in from. As far as posting questions, post questions in the Q&A tool, not the chat. It helps us keep track. We'll address the questions at the end of the session. Again, please post them in the Q&A tab. Each session runs 59 minutes and will keep you on schedule. And I'd like to point out that this session is made possible by our sponsors, Cirrus Link Solutions and HighByte. With that out of the way, let's dive into today's discussion. The session is titled The Connected Factory, Driving Real-Time Insights with OT Data and the Unified Namespace. Hi, I'm Rick Franzosa. I am the Vice President of Research for Manufacturing at TechClarity. I cover MES, MOM, transitional technologies that support evolution of manufacturing software technology into the age of Industry 4.0 and AI. I was a Gartner analyst for 10 years, covering manufacturing technologies for the Supply Chain Research Group. Prior to that, I was part of several software companies focused on manufacturing technologies such as MES, shop floor control, electronic work instructions, and PLM. We have three incredible speakers today, and I will have them introduce themselves, starting with Arlen Nipper, the CTO and President of Cirrus Link Solutions.
Hello, everybody. Thanks, Rick. So again, my name's Arlen Nipper, and I'm the CTO of Cirrus Link. I've been doing industrial automation, infrastructure, protocols for the last 46 years. 25 years ago, I was very fortunate to be able to work with Dr. Andy Stanford Clark, and I was one of the co-inventors of MQTT. It's been pretty incredible to see really where MQTT has gone. And in the industrial space, really it's been one of the foundational technologies for creating the unified namespace. So I'm very interested in this discussion today. Thanks, Rick.
Thanks, Arlen. Next, we have Jeffrey Schroeder, Product Manager from HighByte.
Hello, everyone. Jeff Schroeder, Product Manager at HighByte. I focus on product strategy as well as ecosystem integration strategy. I have a background, 10 plus years working in automotive industry, so very familiar with all sorts of technologies that you would need to use to build and design automotive products, as an example, as well as manufacturing them. Excited to be here today.
Thanks, Jeff. And finally, Tim Long, Global Head of Manufacturing at Snowflake.
Yeah, thank you so much, Rick, for having me. At Snowflake, I have the privilege of leading our focus on the manufacturing industry and meeting with hundreds of our customers every year, helping them on their digital transformation using data, analytics, and AI. And I'm thrilled to be joined by my colleagues and friends here from Cirrus Link and HighByte. So thank you for having me.
Great, great. So what we have done is we've broken down this topic into three sections. The first section is going to be on cloud, data, and infrastructure. The second section specifically on unified namespace. And then the third, to wrap it up, will be the impact of artificial intelligence on this area. So first, we'll ask Arlen a couple of questions about cloud data and infrastructure. So what do we mean by real-time data? Does industrial operational data just show up?
Well, yeah, real time is always relative. So real time, if you're in a closed loop control system, real time might be milliseconds. If you're on a SCADA system, monitoring equipment, that might be 5 to 10 seconds. And by the time you get to the cloud, really, things that we look at are, hey, the data gets there in, 15, 30 seconds. That's probably, what you would call real time for cloud computing.
That's an interesting topic because real time gets thrown around in all kinds of contexts. And, and I got it, my Twitter handle was Real Time Rick. So,
Yep.
But so where should we measure context in machine modeling, and where should that occur?
Well, from my perspective, one of our tenets, I've been working on probably for the last 8 years in helping customers migrate from their, siloed SCADA or DCS or factory control system into, cloud infrastructure. And one of the key tenets is if you don't organize your data, if you don't have that machine definition, and you're just sending process variables into a data lake, you're ultimately going to create a data swamp. Invariably, nobody knows where the data came from. You can't contextualize it. You're trying to look up the engineering units or the scaling factor. So I think one of the really important tenets is to be able to organize our data. I know we're going to be talking about unified namespace later, but to be able to have your motors and your pumps and your valves and your tanks all defined and contextualized so that when you get it in the cloud, then you can apply things like what Snowflake does is have your anomaly and your AI and your LLM models sitting on top of those machine models.
Yeah, excellent. That's I remember back in the day seeing somebody, and it was also probably Twitter saying, "Collect everything, sort it out later." And that's not really a strategy.
No, that we're finding, we definitely have proven that there are so many data swamps out there right now where literally, we'll work on a project, we'll, have this data going into a data lake, and I'll come back and say, okay, guys, what are you doing with it? Oh, well, we're not using that. We haven't figured it out yet.
Yeah. I heard that from a very well-known supplier of these.
So, I think really what you have to do is try to figure out what you're trying to do with cloud.
Mhm.
Before even taking any data up there. Try to figure out what problem are you trying to solve, and then be able to demonstrate that, for a very small subset of your entire factory or pipeline or whatever you're working on. But without that, I think many projects are exercises in, oh, I've got cloud connectivity, I've got data in the cloud, and nobody's using it.
Just another repository. So moving on to Tim, back to the infrastructure question. How are digital twins being used in manufacturing to optimize processes, predict failures, and accelerate innovation?
Well, digital twins are still, I think, emerging in manufacturing. Many of our customers are asking about how they can build these, and they're really exciting, honestly. But they all start with capturing the data that is a digital representation of an asset, a process, or a system. Like a factory itself can be a system. And then once you have the data, which often is coming from those sensors, and it's a question of what do you do with that data? And customers generally start with visualizing, understanding the performance of the twin, and then moving from there into things like simulations. And once I understand how all these sensors work together and how they affect the output of my process or my factory, then I can start to manipulate the variables and understand the potential outcomes if I made physical changes to that asset, process, or system. So predictive maintenance is a great application for these digital twins. Process engineering on the shop floor is a great opportunity for these twins, and so many others.
Yeah, for sure. And I think a key point that you made in there is that I think initially people thought about digital twins as twins of physical objects, but the digital twin of a process or a digital twin of a facility is also extremely important. We even had people working on digital twin of an organization, so which is really out there. So what's the role of cloud in manufacturing today, and what do you think it will be in the future?
Well, the role of cloud in manufacturing is really a hybrid role. Of course, there's many things that continue and will continue to be jobs for on-premise compute. things that need to have zero latency, things that need to have extremely high availability and security, those still live on premise and run the shop floor for things like safety or other high availability production processes. The cloud really provides a role for data to be brought together, unifying that data across the IT and OT environments, and even connected product data for those manufacturers who build products that have power. Those things generally create data, and those data can be brought together with the rest of the enterprise data in the cloud. And then from there, of course, enterprise-wide visibility, supply chain use cases, smart manufacturing, AI solutions can all be developed. Some of those run in the cloud, and some of those will be deployed back to the factory depending on their needs.
And what features would you recommend for a manufacturing cloud infrastructure?
Well, I mean, there are several. I'll list maybe I think some of the most important considerations for selecting cloud infrastructures. One is, of course, the security posture, making sure that you are protecting your intellectual property and that you have a high faith in the governance that it will be supported by your cloud solution. The second thing is really thinking about having the scale when you need it. And I mean having an elastic environment that can scale up on demand for big processes such as training machine learning models, and then also scale down very quickly when you don't need those resources. And then third, I would say making sure that you're selecting a platform that really can support all types of data at all types of velocities. So bringing data from ERP systems, shop floor systems, or IoT devices, for example, including unstructured data like images, videos, documents, etc. And then lastly, you would be remiss if you didn't pick a platform that had great advanced analytics capabilities, machine learning, and artificial intelligence to really find the useful information or insights from those data and bring them into decision making, sometimes as advisors, sometimes as automated decision making agents.
Excellent. Thanks, Tim. And finally, Jeff, we've talked about cloud and data and infrastructure. We're going to be moving into the whole conversation on unified namespace, but what different architectural patterns are organizations adopting for UNS?
So first off, there's a lot of interest in UNS, and I think that interest is being driven by different downstream teams, or what I like to call data constituents, if you will. These constituents get work done in different applications and services. They have different requirements and patterns of access, and I think that's kind of influencing different architectures. So first, most commonly, pub/sub, publish and subscribe architectures are fantastic for real-time access. MQTT especially is very efficient for distributing current state of assets and instrumentation. And we have Arlen to thank for pioneering that. But we're also seeing other architectural patterns augmenting and complementing that approach. So some applications might have more ad hoc or transactional access patterns. So we have users building APIs as their point of access to UNS, and this provides a collection of services of methods that can be invoked, and they're semantically consistent. The other scenario that we're also seeing is some users, want to closely observe a manufacturing process. We talked about latency earlier. These users want real-time feedback or fast, continuous calculations. Time series technologies and historians are certainly great for this. But there's also broader access needs to support analytics, business intelligence, data sharing, and AI. Data lakes and data warehouses are good for that. We have players like Tim from Snowflake here to thank for that. At the end of the day, all these technologies have very different organizational data organizational paradigms, whether it's like schema in databases, topics and payloads in a message broker, tag hierarchies, asset models, and historians, and so forth. What we see is that industrial data ops makes it possible to provide consistent semantics so that at the end of the day, the UNS can be aligned to how users want to access data and when they want to use it.
Great, thanks. All right, well, now that leads us to our next topic, which is UNS. So I'll stay with you, Jeff. What is the appeal of UNS and what is driving interest?
So first off, I think in industry, all the different systems or producers of data are kind of inherently sticky. We're all aware that there's a variety of specialized systems and assets, and they can certainly be old. But we also have to consider the cost of changing those things. It's not just the acquisition cost to say, hey, a large press is expensive, but you also have to think about is, what did it take to install that thing? What did it take to integrate that thing? What did it take to train people on it, validate it, maintain it, and so forth? So standardization is extremely challenging. It's not like an IT project where you turn over, devices every 3 to 5 years or something like that, right? So industrial data, just by definition, is going to be kind of chaotically heterogeneous. I think UNS is appealing because it takes a lot of different data sources without necessarily modifying them, and it brings them together in one logically organized place. We're seeing UNS adoption across many verticals, everything automotive, consumer goods, pulp and paper, food and beverage, energy, utilities. I'll say one of the hottest right now, or I see where people are putting, there's a lot of major interests, especially in life sciences right now. Life sciences, especially pharmaceutical, those are very complex environments, and those data sources are extremely sticky, as we kind of mentioned earlier. So I think UNS breaks down those data silos.
So pharma, interesting. So does this help them with, things like the regulatory compliance issues that they struggle with, or?
Yeah. I think a lot of it comes down to, because it's effectively decoupling the producers and consumers of data, right? It makes it easier to swap out, let's say, a consumer of data without necessarily impacting the producers, and creating, a new chain of things to validate over and over again.
Okay. You sort of answered part of this next question about where are you seeing it being adopted, but what are the use cases that you see that are most prevalent?
Obviously people can have a lot of assets, right? And they're concerned with keeping them up. But I think a lot of interesting scenarios that I've seen are things that are related to monitoring particular processes. In many cases, sometimes it could just be operational, because in some industries, like for example, life sciences, right? If you don't document things, you may as well have not even produced them, right? So the idea is that the way that if you can bring more data efficiency to pipelines, you can democratize better access to that data. That's one particular area. We've seen things like AGVs as an example. Imagine you try to standardize on one builder of AGVs in a facility, but 5 years later, maybe the manufacturer of that changed the assets, the models and series themselves. Maybe they have different interfaces on there. So, or you happen to acquire a different company, or you merge with a different company, or your supplier went out of business. So you end up with this sort of heterogeneity on there. And so how do you make an AGV look consistent in the downstream systems, right? You don't want to have you don't have a swivel chair between every different make and model that you have in your enterprise, just to be able to know which AGVs are active, or what tasks are they currently assigned with. Great.
So what does a UNS look like throughout an organization's digital journey? What data, team organization, those sorts of things?
Yeah, so I think in terms of journey, it varies by digital maturity. I think OT-centric, or maybe teams that are focused mostly on data producers, so meaning just like, let's just log data because we have to observe a process, right? Or maybe less digitally mature team where they're not using specific downstream applications to use data and so forth. They might start with simply just unifying their disparate asset data. And I think that's a perfectly good thing, because if you've never seen all that data in one place, or how it might vary, that's great to finally get that in one place. I think the other teams that are a little bit more digitally mature, where they might already be doing things outside of the industrial domain that are maybe kind of considered cutting edge or more advanced. They'll start with downstream applications and services, and then they'll work backwards. They'll focus on high value use cases. The best teams that we generally see are kind of cross-functional nature. So meaning that they have some representation, they have some background of experience and domain expertise about the business, but they also represent the producers of data. So the systems that create data sources as well as the data consumers, where data is being used, right? So they understand why that needs to be consumed. They generally maintain a backlog of use cases and execute on high value ones. But these organizations ultimately see UNS and its data as sort of an internal product. And it's something that is then strategically supported and resourced. So some orgs we're even seeing they actually have dedicated data ops teams where they maintain a UNS or they're democratizing access to data in the org, and that's their core mission. That's where we see the most digitally mature orgs.
Yeah, so I mean, we may come back to this, because it'd be interesting to know if you've got any specific examples. Maybe you can't mention names, but of some really unique stuff that you've seen. Is that something you could? I know I'm just kind of throwing it at you unprepared.
Yeah, I mean, some scenarios. I mean, the productivity improvements blow my mind. Like, I mean, we've have some organizations where they have literally hundreds of plants, and there might be teams as small as just a handful of people managing all those data pipelines. Whereas, at best, years ago with the technology, I mean, this is the exciting part, especially with all the my peers from these technology vendors and so forth, is the options even just, I don't know, 10, 15 years ago weren't nearly as good as they are today. And the productivity gains that organizations are seeing, I think it's sort of incredible because, you would have probably had to have at least a full-time resource at each site just to kind of manage that with incumbent technologies. And nowadays, whatever, you're just seeing this like force multiplier effect with the confluence of technologies today, so that makes that a lot more possible.
Great. Thanks, Jeff. Arlen, what does single source of truth mean in the context of UNS?
Well, I'll go back to what Jeff said. We are just, we're at the tip of the iceberg of the opportunity here. Remember, from my standpoint, I've got 46 years of equipment that's been going out there. So we had Modicon 484 PLCs that companies still have in their factory.
Oh,
right?
Yeah.
So we've got this huge swath of technology, as Jeff said, that's sitting out there producing the data. But from my standpoint, what we really, up until just a few years ago, we had siloed SCADA systems, DCS systems, factory control systems. The engineers were sitting there. We poll it. It goes on the screen. The data falls on the floor. Then IT would come in and say, hey, can we have some of that data? And go, no, that's not your data. It's my data. You can't have it. So, we've gone from that to where, in my notion, is the single source of truth is that we've got data from a PLC or an RTU or a LoRaWAN or a 4 to 20 milliamp transmitter. We capture it, and then nobody touches it all the way to the cloud. And I think that really is the single source of truth, where if we've gone from a Purdue model where you had level 1, level 2, level 3, level 4, and everybody touched the data, and by the time it got to the enterprise, the data was worn out. Mm-hmm. And nobody knew really where it came from, or who added context to it, or who subtracted context. And we were hand entering, oh, well, I want data from my Modbus device. I'm going to re-enter the engineering high and engineering low for my Modbus register 40,001, and then somebody upstream, they entered the wrong engineering high, engineering low. Now they're working with bad data and they didn't even know it. Mm-hmm. So to my standpoint, we're really having, and like you said, the technology to get edge of network devices out there where you gather the data once and you publish it into your UNS, and then that becomes the single source of truth that you're working on.
Right, and people can still extract it and do whatever they want with it.
Exactly.
Exactly. And so I'm going to throw you a question that's not on the list here. How do you see that impacting IT and OT organizations?
Well, first of all, I think from my standpoint, the single source of truth means that engineers, technicians, everybody from OT, their job is to make data humanly understandable. So one of my biggest pet peeves is that in industry, we are awash with enumerations. So we have a perfectly good flow computer, and it has an orifice material definition that's 1, 2, 3, 4. Now, we know that one's Monel, and 2 is stainless steel, and 3 is carbon, but our job with the UNS is to define that right at the source so that when IT get that or when the enterprise get that, they go, oh, orifice material is a 2. Well, what is that? So it's really giving context to register values for what Modbus register, a Allen Bradley register, a Siemens register, N5 40001. Well, let's give it a name. Let's give it temperature, pressure, RPM, and then let's try to capture engineering high, engineering low, dead bands, all of that contextual data that when it arrives at the enterprise, now a mere human being can understand it.
Mm-hmm. Absolutely. Can you discuss methods for easing and simplifying the implementations of a unified namespace?
Well, from my standpoint, SiriusLink, that we've worked very hard with MQTT. We came up with the Sparkplug spec, and the Sparkplug lets us start actually publishing models from the edge into the cloud so that we have a model of the pump. And now we can instantiate that and have, 15 models of that same pump and be able to leverage that. There are a lot of tools like HighByte to be able to do that with a data ops tool that you've got on the edge. So you've got technology out there like Ignition, like HighByte, like the SiriusLink modules, and going into capabilities that we're all leveraging with Snowflake.
Great. Okay, Tim, I didn't want to leave you out here. How are manufacturers bringing IT and OT data together in a UNS?
Yeah, well, the first thing that we generally see for the manufacturing customers is they begin with their IT data. These are generally, much more easily accessible for manufacturers. Many of these systems are cloud native already, and they're able to tap into those sources, bring them together from their ERP systems, including SAP or their CRM systems, or any of their supply chain systems. They tie all that together. Mm-hmm. And then what we're seeing more recently is really this pursuit of bringing OT data to the cloud. And that's where our partnerships with HighByte and SiriusLink come into play, where both these guys make it incredibly easy, efficient, and secure to bring these data from the shop floor to the cloud. And they begin to then bridge across IT systems and OT systems to truly understand things like OEE. What is driving my quality issues at this step, at this particular piece of equipment? Why is the availability of this machine not as good as this other machine? This requires a tremendous amount of data coming from both these IT and OT environments. And the good news is the technology all exists now to liberate these data from these systems on the shop floor and merge them with the rest of the enterprise data. And we're really excited to see our customers do that.
Great. Well, that closes out the UNS section. Now on to our final and favorite topic of the day, which is AI. And Tim, we'll continue with you. What steps are manufacturers taking to position themselves for AI success?
At Snowflake, we talk a lot about you cannot have an AI strategy without a data strategy. So we're seeing a lot of customers invest in the fundamentals. This includes strategy of, how are you going to approach this integration? Which technologies will you choose? How are you going to ensure that these data, once you have them, have high quality, are discoverable, and then, of course, are accessible, but also secure to your enterprise? Mm-hmm. And then, bringing that together in a strategy really puts organizations in a position for success to leverage AI solutions on top of that data, because they need to know they can trust the data. They need to know that the data are secure and will not be leaving their environment, and that they can trust the answers of AI because they've taken all of these appropriate steps to really build out a robust data environment for the artificial intelligence.
So is AI essential to Industry 4.0, and in what ways? I'm a skeptic, but let's
Well, I'm the opposite. I'm an optimist there. I really see it as essential, absolutely. So I think of, Industry 3.0 was all about, bringing computerization, automation to the shop floor. How can I automate tasks to improve speed, reduce cost, and reduce variance in the manufacturing process? And Industry 4.0, to me at least, is all about that next step, not just automating tasks, but now automating decisions. And AI is truly essential to that. Now, I think of machine learning as part of the AI family. It's not, all about generative AI and large language models. And absolutely, machine learning is critical for any high-performing manufacturing organization for, very simple reason that it's physically impossible to visualize the multivariate concepts that are in play for some of the most challenging manufacturing problems. I couldn't visualize 5, 6, 7, 8 dimensions of data simultaneously to really understand how different things are working together to lead to yield or efficiency issues. And so that's really where machine learning plays a huge role today. And AI just makes that even more accessible. Generative AI through creating conversational experiences, working with those machine learning algorithms and bringing out those insights. So I absolutely think it's essential to successful Industry 4.0 programs.
Yeah, sure. Jeff might know this. I attended a Plex conference years ago, and they had a row of seats in the front specifically for analysts, and they had a name tag, a big name tag on it that said "Curmudgeon Row." So the skepticism comes naturally for anyone who's a research analyst. So where is AI disrupting and creating new value? Do you have some real good examples?
Oh, there's so many examples. I mean, just picking on the dashboards again for a moment, because I think this is important. A lot of organizations are still trying to build out a visual representation of their business. And the problem with these dashboards is they have limits, right? You have to think in advance, what questions I'm going to ask of the data, and you need to build the presentations of those in advance. And the problem with those is the minute you have that first question or second question on the data, you immediately exhaust the capability of the dashboards. And even the best technologies for dashboarding have their limits. And so what's exciting about AI in a conversational assistant or a chat bot is you can ask these questions now, very complex or nuanced questions, and with the appropriate data modeling and the right technologies, you can get back incredible insights just asking specific questions. In fact, we have a demo that shows some data from our partners here that we've loaded into Snowflake, and you can ask questions: which machines have the top 2 defect rates? When was the last change to those machines? When were they last serviced? These are all natural questions that you would otherwise have to hunt and peck through a series of dashboards to find this data if you can get to it. So that's a place where we're seeing immediate impact. There's so many other places, though. I mean, large language models, our customers are loading their repair manuals or their work management data for their equipment, and they're learning from those repair manuals. They're learning from the historical records of what type of maintenance activities have been performed successfully to repair certain situations. They're using these large. I'll tell you another interesting application. We're working with customers to do part similarity matching or substitution. So supply chain is a real big challenge for manufacturers these days, and they can use these models to say, hey, out of all of these parts that we have, which is most similar to this particular part or assembly based upon these properties, and they can use that to shortlist potential substitutions and bail them out of some of these supply chain challenges. So there's just an incredible opportunity everywhere. I will say that the technology is there, and it improves tremendously every week. We see new versions of these models. A new one jumps to the front as the best model in the market for a particular application, and that's exciting. But where we see the most success in our customer base are those who not only focus on enabling this technology, but also focus on how to educate their workforce to use these technologies correctly and safely, and also in the places where they are disrupting business processes and they're introducing a change, that they're doing that through appropriate change management as well. So it's incredibly exciting what AI can do, and where we're seeing it make a big impact. And those organizations that focus not just on the technology, but also the people and the business processes are those that are having the most success.
Mhm. You know, I had the opportunity to sit with the heads of various product organizations for one of the really large software providers, and I asked the question about, how are you applying AI? This was probably late 2023, early 2024. And most of them, their answers were kind of like, well, kicking the tires, But the one thing, it's resonated with what you said. The one thing they mentioned is like coding standards.
Mm.
Have we developed coding standards over the years? Sure we have. Are they documented? Yeah, somewhere. However, we can not only use these large language models by taking all of the stuff we have and synthesizing that, but also looking at the results of people writing code and being able to then learn from that, here's really the better way to do that if you're writing this sort of code, or here's some code already written that will do what you're looking for. So so it is exciting. I don't want to be too much of a grump here. All right, so thanks. Thanks, Tim. So Jeff, how are you addressing historical data transactions in AI/ML?
Great question. Yeah. So as I mentioned, we're seeing users adopt different architectural patterns. I think for historical data, our users don't just often take, they're not just historizing the UNS saying, hey, I'm going to monitor the events and capture their events for their historical context. But in many cases, if you think back, users did start in Industry 3.0, right? They already have historical data in many cases.
Sure.
And that historical data already has some context, right? We're not exactly doing our jobs if we just take, we scale a 4 to 20 milliamp electrical signal into a decimal place and then send that to the IT systems and say, here you go, my job is done. That's not really enabling line of business users. But the other issue is that, so there's a lot of context in those historians or wherever historical data already resides.
Right.
But in many cases, it might span multiple time series and historian technologies, and those might be owned by different teams. So what we also see is that some users might start off with those things as a data source. So they'll build like stateful data pipelines. They'll extract the data and land it in a unified way in some enterprise data platform. That might be one approach that they're approaching the historical data. So literally they move it. The other thing that we're also seeing with transactional integration patterns with the UNS is you might have something like an MES, and in some industries, the MES doesn't just react to the automation, but the MES drives the whole thing. Right. So it might be, I'm at the next phase of a batch. I need to call and sample something on there, but it could be a nightmare if you have lots of different instrumentation or lots of different data sources, right? So but being able to access that through a UNS or expose that as almost as a service, as an API that can be invoked on demand by an MES works quite well. But the other thing that I also think that's really useful with considering UNS as an API for these more complex access patterns is agentic AI, right? If you think about what everyone's doing with AI right now and all the interest, a lot of it is prompt-based, right? Or the agents need to be able to discover which endpoints are available. They need to be able to call those. They need to understand the context of them on demand. So I also think being able to kind of expose things as services that are discoverable, because it used to be in many cases, I think when we first started Industry 4.0, it was kind of like, hey, let's start pumping data to a destination. But now it's kind of, hey, we have these agents everywhere. They need to be able to call us. In other words, we need to expose ourselves in intelligent ways. And I think that's something that also needs to be considered.
Yep.
Great. Arlen, what is the relationship between unified namespace and successful AI implementation?
Well, again, it's that I'll go back to what Tim said. I like the context that he put that in. Is that, my background, the first 25 years was in oil and gas, and we put up displays that we had a pipeline, and every booster station we had suction pressure, case pressure, discharge pressure, and a human is sitting there trying to optimize that throughout the process. So you can't have enough eyes to be able to really understand what's going on there. And it's not that humans are stupid, but like you said, if I'm going to watch all 50 booster stations at the same time, then that literally could improve the entire process. So I think trying to get that in, then, from a UNS standpoint, again, all we're talking about is organizing the data that we already have. The UNS isn't inventing any data. We're just taking stranded data. And believe me, I've done many, many studies with many different customers, and a lot of people, don't agree with me, but we're still leaving 80 to 95% of valuable information stranded in the field. I'll go back to what Jeff said about a 4 to 20 milliamp loop. We don't realize that all of our smart transmitters have hundreds of pieces of information in them, like the serial number, when they were last calibrated, and all this other information. So being able to take that, put it into a UNS that really drives what we're trying to do. And that might be, the same data point appears in several different contexts in our UNS, so that we have one context that is the overall, okay, this is what I want to do with AI. I've got to have a model for that particular application.
Right.
And then I think you said it before, Rick, is that, a UNS might be a process. So I'll have a UNS for a pump, a motor, a valve, but then I'm going to put those all together and that becomes a booster station. And then I put those all together and that becomes a pipeline. So I think we're just kind of touching the surface on what's the best way to take existing machine data, get it into a UNS, get it published up, and then be able to start utilizing that. And I think we're still, like Tim said, every day we're learning what we can do with that.
That's great. That's great. And it's an interesting topic just from the standpoint of the data issue. When I want to say early in my days at Gartner, we had the thing called predicts, where it's a prediction that we're making, and we were predicting in, let's say, 2015. We said by 2018. 60% of data that is collected on the shop floor will not be used. And, it was outrageous, right? And then in 2020, I saw an interview with a guy who's one of the CTO of ABB, and he said 80% of data being produced is not being used. And so, the issue is you look at IoT, you look at low-cost sensor technology. You look at the whole idea of IT/OT convergence, or I should say alignment, which of course, Arlen, as we know, started the first time they put an Ethernet port on the back of a PLC. Data, you're not hurting for data. It's the other way around. And I think that's one of the things that the tools you gentlemen are talking about this morning really, it is really going to make a difference. We've still got a little bit of time here. The questions are coming in. Oh, by the way, all of you out there, we're going to spend the final 10 minutes on Q&A. And so get your questions in, go to the Q&A tab, get your questions in, and then, we'll manage as many as we can. But I'm going to go around one more time and just ask each one of you, starting with going reverse order. I'm going to start with Jeff. What do you feel is the biggest challenge in this particular space from your viewpoint, from your lens, and the biggest opportunity?
Increasingly, I always think of people process technology, and again, maybe I'm biased because I'm in the vendor space now, but I feel like the technology has gotten pretty good. I think a lot of it comes down to people and process, just kind of internal alignment. The thing that I do think that's increasingly challenging is as we've as organizations, as industrial organizations have gotten more sophisticated, they have more and more automation. Some of their processes are more sophisticated. They have applications that are doing more. I think it's harder for teams to understand all that stuff holistically. The amount of people that you can find that have good fluency in all those different areas is quite small. And sometimes it's amazing sometimes how challenging it can even be for someone who might work on control systems of an asset all day, but they might struggle to figure out, how do I develop a decent data model or decent schema for what this industrial asset does, such that a downstream user who has no domain expertise about this can intuit what's going on. And I think there's almost a shortage of use cases. I think people don't have problems, but putting those into action, I think, is sometimes difficult just because of the landscape of how organizations are kind of set up today, and just how fast all the technology is moving.
That is such an issue, and it's like the paradox of domain expertise without understanding data science, and data scientists who don't have domain expertise. You have to get that together, and I think the development of the tools is helping that. I didn't like the term citizen data scientist, but we've all heard it. But just kind of getting to that point where the person who understands the pump has better tools to build a data model. Tim, how about you?
Well, first of all, I agree with Jeff, and maybe another one I'll add, though, is I see organizations sometimes struggle with where to start and where to invest next. And to me, I always remind them, well, let's talk about your business. What are the things you're challenged with? What business outcomes do you need to achieve? Where do you need to improve? What KPIs stand to benefit the most? And then we can identify the use cases to affect those. And from there, we can identify the data, and we can bring it from IT, OT, or IoT sources together. That's the easy part. To Jeff's point, the technology exists to make that relatively easy to implement and fast to implement. So really, I guess my perspective is it's all about understanding that business impact, business value, and then working your way from there down to the data investments you need to make.
Great. Arlen, you want to take us home?
Well, again, I agree. We have customers that need to do due diligence on what do they have out there. And it's one of the hardest things to do. They'll go, oh, we want to do this and, integrate this. And we'll go, well, what PLC do you have out there? Oh, I don't know. So then there's the other. So my background was oil and gas. We tended to build our own infrastructure, program our own PLCs. But lately, with the UNS and with this whole ecosystem, we've gotten into manufacturing quite heavily. And I guess one of my other pet peeves is that people are buying machines that nobody will tell them how they work. And they go back to the manufacturer, and the manufacturer won't give them that information. And I think we've got to get to the point here, just like open source, Sparkplug is open. We all know how this stuff works. But yet I'm a manufacturer and I've got a machine that's a black hole.
Mm-hmm. Yeah.
So, we can have these discussions all day long, but we do have to democratize data from everything that we're putting in our factories. And maybe, it's part of the contract that, hey, if you don't, give me a register map of the machine, then I'll find somebody else to buy it from.
Absolutely. And to actually going back to what Jeff said, I gave a joint presentation with a gentleman from Lockheed Martin back in 2017, and they were building their own data bus because of the fact that they didn't feel that any of the enterprise suppliers that they had could do the whole job. And he put up this slide that said, people, process, data, technology. And I always felt, yeah, that's really it. And in that order. Because the technology is not going to be worth anything if you don't have the data, you don't understand the process, and the people aren't aligned. So yeah. All right, so we actually have some questions here. The first one, it says, hello, aside from LLMs, which are good at surfacing what is already known, Are any of you using DNNs or other ML to analyze the noise in analog electrical signals to detect machine problems?
I guess I'll take a crack at that. I'd say that goes down to an instrumentation level. So there are probably solutions in the industrial domain. I feel like most of us kind of focus at a certain level above that, or whatever, where we might be looking at the exhaust of the data exhaust of those systems. But what I have actually seen among a couple of users is increasingly for them to detect in classified downtime, because some manufacturing processes are it's sometimes non-trivial to determine state of an asset in some cases, because it might be down, but you might actually need to cycle that asset for the purposes of troubleshooting in some cases. And relying on a human being to say, well, I need you to classify this as down, but I'm actually going to cycle it like 5 times in a row so I can diagnose it along the way. That gets quite murky. We have seen some customers where they actually will take those raw events and actually send those through machine learning models to derive clean events that are having down there. So the idea is that they can actually have more effective downtime reporting and escalation, if you will. So I would say that's probably the most adjacent thing that I've seen is ML to again basically take the signal out of the noise, so to speak.
Okay.
I'll give it, maybe if I could jump in and add an example of, we see convolutional neural networks being deployed, which is a type of deep neural network in the case of computer vision. And that's a really exciting space. I don't think we've really gotten into that topic here, but the idea that I can use cameras to detect defects in the product without adding process time, without slowing down my cycle time, to have somebody pull that out of the process, manually inspect it and put it back in, that's a game changer. And those are becoming more and more accessible, including in our technology, to be able to run those. And there's so many other opportunities, recurrent neural networks for detecting anomalies, autoencoders. I mean, there's so many different techniques within machine learning that are more easily accessible today, especially with the availability of things like GPUs, that can really make these things possible to create, deploy, and get value out of in a very short order.
I wish I could remember the example. Speaking of vision systems, I don't know the company, but they were using vision systems. They were cascading grains of wheat. And when the vision system spotted a discolored grain of wheat, a puff of air would knock it out of the stream.
I saw
amazing.
Yeah, I saw a video just today. They're doing the same thing with tomatoes that aren't ripe, and they're falling. They're falling through the air, and they have little fingers that tap them to knock them, out of the default path for unripe tomatoes. So, this stuff is real, and it's providing a ton of efficiency in manufacturing processes.
Great. Arlen, this question was aimed at you. Others can jump in, I'm sure. It says, Arlen Nipper, love the discussion of data dropping to the floor. We see so many older legacy systems still relevant today. What is the biggest impediment to getting the data connected to provide meaningful information, or uses do you believe? Or uses do you believe? ? And more importantly, how do you get to the non-tech users, product managers, marketing, et cetera, to use it effectively?
Okay, well, I'll try to answer that very quickly. Number one, and I will go into the weeds on this. If it's RS-232, if it's RS-485, hey, there's technology out there to be able to do that. You've got to be able to, somewhere there's documentation on that equipment so that you can get that data out and then get it contextualized. Again, you're talking to me, to Jeff at HiByte. We've got the data ops tools to be able to contextualize it, to take enumerations and expand them out so you can understand them, to rename a cryptic process variable name to something that makes sense, to be able to put it into a model that says, oh, I see that. That's a flow computer. Oh, it measures flow. I don't have to be a rocket scientist to understand all of the other aspects of that. So there are definitely the tools out there to be able to even take 20, 30, 35-year-old equipment. Man, over half of the flow computers, I'll bet, in the oil industry have been out there for 20, 25 years. And we're still finding ways to interface to them because the physics of measuring flow really hasn't changed much.
Great, great, thank you. This one's for Tim. I've been playing with the Snowflake since attending the North Star Builder Workshop in Chicago and wondering if you could point me to a webinar/training to experience its capabilities in building the pipelines with manufacturing data.
Well, I do about one webinar a month with these two fellas right here. So there's plenty of existing resources on YouTube. That's a great question. I would say drop me an email and I will get you some materials, tim.long@snowflake.com, and we will set you up with exactly what you need to get started.
I would suggest the Accelerate Manufacturing series that was about a month ago that you guys hosted.
That's a great one, Jeff.
Buffet.
Yep, I think that's available either on the Snowflake website or YouTube, but Accelerate Manufacturing is a great one. Thanks, Jeff.
Excellent.
Can I chime in on the question that Arlen answered?
Sure.
Yeah. So I think a lot of people who are exploring this particular space, they have a tendency to focus on the middle. So meaning, hey, I'm moving data from A to B. I think we need to focus more on A and B. So if you start with the data source, Arlen brought up a great point about machine builders that are, we'll just call it more or less hostile about data access. I think that is problematic. The fact that there isn't a browsable interface on something and there's no documentation of what those registers are, that's a problem. I think obviously companies should probably put commercial pressure on that, but dare I say, maybe this is a little bit more barbaric, but maybe we should just start shaming machine builders when they don't do that or whatever, because that's a real life impediment that causes a lot of downstream problems. It's pervasive in different parts of the industry. The other thing that I'll also say is to getting started is focusing on those data consumers or data constituents, if you will. If you don't know what the use case is, you probably need to spend more time with your coworkers. So they probably have a spreadsheet somewhere that they're using to do something. That's a good basis to kind of get started and work backwards from.
Yeah, somebody once told me that the acronym MES stood for multiple Excel spreadsheets. So great. Well, thank you, gentlemen. If anybody has any final thoughts, we're at the 12:57 mark, so we got 2 minutes left. If anyone would like some final thoughts, otherwise, this was great. This was really enjoyable for me. I guess one comment I have when you talk about machine builders, I would say that one of the things I've noticed when I've talked to people is that a lot of the machine builders try to build their own software front end, which is typically an example of why machine builders shouldn't be building front ends. Is that part of the problem as well?
I would say, yeah.
Go
ahead.
Go ahead. Well, they think that they don't realize that they're part of a whole ecosystem in a factory.
Right. They are the ecosystem.
Yeah, I understand that they think it's special, but it's got to integrate with everything else.
Yeah, absolutely.
Yeah, let's say I always laugh sometimes when you go to those trade shows that have like a lot of the machine tools at them, and they think that, hey, even this, you saw this 10, 15 years ago, everyone was into mobile apps and everything like that. And they say, hey, we can have our own app store and ecosystem on there. And it's like your total addressable market or the volume that you ship of machines is 200. For this, it's like billions of users per year. You really think that your ecosystem, it's like, no, you have to Arlen's point, you're a part of an ecosystem, whether you realize it or not.
Right.
So don't try to reinvent the wheel. Right.
And it is extremely rare to find somebody who's just going to buy from one vendor. It boggles the mind that people don't understand that, because that's really the real world, and it doesn't matter whether you're talking about IT systems or pumps or anything else. In the real world, people have choices, and they're going to make choices, and they're not going to standardize. And even if they do standardize, then they're going to buy somebody else and try to integrate their plant in, and that plant uses something else. So there we are. All right. Well, Thanks. This was so enjoyable. I really appreciate your time, guys.
Thank you.
Same to you, Rick. Thank you.
We'll see you.
Bye for now.